This combination of bulbs is part of an electric circuit. If a similar bulb is added to the combination in parallel, then the total resistance of the combination will change how? And the total current will change how? So here we have the original combination, and now we add another bulb in parallel. How does that affect the resistance of the circuit and the current strength through the circuit? Remember previously we've asked, how does adding resistors in parallel affect resistance? And how does adding resistors in parallel affect current strength? We used 3 circuits. One had only one resistor together with an LED. The second one had 2 resistors in parallel with one another, and the third circuit had 3 resistors in parallel with one another. We can compare these 3 circuits to 3 water circuits. The resistors are like narrow pipes. The good conductors are like wide pipes. The water flows easily through a wide pipe, but a narrow part slows the water down everywhere. When we have only one resistor in the circuit, it's like having only one narrow part of our water circuit. When we put another resistor in parallel with that, it's like having 2 narrow parts, both leading the water from the right to the left. So some of the water can go through this top pipe and some of it can go through the bottom pipe as the water moves from right to left. The water has a choice, we could say. And then in this circuit we give even another choice. We have 3 choices of paths that the water can take to move from right to left. In a similar way, in a circuit with 3 branches, 3 resistors in parallel, some of the charge can go through this resistor, some of it can go through that resistor, and the rest goes through that resistor. So there are more pathways for the charge to move. In which case is it easier for the water or the charge to move? It's easier when there are more paths in parallel, more resistors in parallel, because then it adds up as if that part is a thicker pipe altogether. It has less resistance. It's important to note that each of these circuits has the same battery. So there's the same voltage pushing the charge around. That's like having the same water pressure pushing the water around in the water circuit. But we found that the LED shone brighter in the circuit with many resistors in parallel, and dimmest when we had only one resistor. That tells us that the current strength through the main part of the circuit is greater when there are many resistors in parallel, and smaller when there are few resistors in parallel. And that's because it's like the water can flow faster when there are many branches to choose from, but it doesn't flow so fast if there's only one path, one narrow pipe that all the water has to move through. In other words, the more resistors you have in parallel, the lower the resistance, the easier it is. And when it's easier, more current flows. A higher current strength is measured in the main part of the circuit. Adding resistors in parallel decreases resistance, so it increases current strength through the main part of the circuit. So let's look again at our question. When we only have 2 branches, 2 bulbs in parallel, it's more difficult than when we have 3 branches, 3 bulbs in parallel, because that adds up to be like a thicker pipe, making it easier. Because of that, the current strength in the main part of the circuit here would be greater. Of course, the main part of the circuit is not shown in this diagram, but we are told that these are parts of a full circuit. So we just remember that, of course, there is a main part of the circuit, and we're being asked about the current strength through the main part of the circuit, even though we're not shown that in the diagram. Now just look at how this question is worded. It says, if a similar bulb is added to the combination in parallel, then the total resistance of the combination will, and the total current will. And then we have 4 options, and in each of the options there are 2 terms. So the first term is referring to the first will, which is about resistance. And the second term is referring to what comes after the second will, which is about total current. I main, in other words, current strength through the main part of the circuit. The resistance decreases as we add another bulb in parallel, and the total current, or I main, increases because it becomes easier. So the correct option is D. Resistance decreases and total current strength increases.